Hi, this is Amy Lewis. This is Engineers Unplugged. Hi, this is Amy Lewis, Cisco Marketing, and we're here for another episode of Engineers Unplugged. I've got Stephen Foskett and Jay Metz, and they're going to be talking about next-gen storage. So, Stephen, take it away.
All right. Thank you, Amy, and thank you, Jay. So, one of the big topics in storage now is this idea of convergence and virtualization. Basically, instead of having silos of special purpose servers and storage that are fairly small in scale, we're getting now to the point where we're having a huge fabric of fiber channel or Ethernet switches that connects many storage devices to many hosts. And so Jay and I have been spending a lot of time talking about all sorts of different configurations that you can have with Ethernet, with fiber channel. And Jay wants, I think, to show a new idea for really building a huge scalable fabric. So you want to take it away?
Sure. Yeah, so one of the things that we've been trying to figure out in the industry is how do we deal with a lot of the environments that are being developed as a result of software-defined networks and software-defined storage now, and what does this all look like? But at the core, there's still an underlying infrastructure that it needs to be maintained and certain design philosophies that we use for storage that we have to keep. So one of the things that Steve and I were talking about was, well, what does it look like? Well, traditionally what we do is we start off with a traditional SAN A-B environment because we need resiliency and we need to be able to make sure that at least if something fails, the other is going to be able to pick up the slack. The trouble with this is that even when you start to scale, it winds up being a bit more, well, there's a little bit more latency, it becomes a little bit more of a complex situation, and pretty soon you're so far away from the storage that now you're starting to impact performance, right? And obviously we still want to keep a SAN A and B because ultimately at the end of the day, storage guys are paranoid. That's what it is. Just like that. So one of the things we were thinking about just in brainstorming is that I think what we're going to see in the future is that we take this kind of paradigm and we put it on its side and it looks something like this. Now, in this particular situation, anybody who is involved in storage can see, oh, that's a mesh topology. Yes, it is. What's interesting about this is that this is an Ethernet mesh topology. And because—
No! Ethernet scares me!
Oh!
There, I'll get that out of the way.
No, it's going to be happening more and more often. We do it again.
Ethernet scares me!
Ah! Okay, so what we do here is we still have our SAN A-B situation, but we always have an edge core edge topology because in this case, we have a leaf spine architecture and every storage related element is on the leaf and the spine is our resiliency for the transportation of our vSANs across the network. So at any given point in time, we only have 1, 2, 3, which gives us very good predictable performance, as well as our SAN A-B topology. And in this particular case, we increase our resiliency the more we put in there because the entire spine would have to go down in order to lose our connectivity into our storage. Even if we lost this link, we'd still have our B. Even if we lost this link, we would still have our A. Even if we lost this link, we'd have many paths to work inside the network. As opposed to here, if we lost this particular switch, this entire part goes down. So we're increasing the resiliency. It's one of the few times where we increase our stability. Say that 4 times fast. We increase our stability and reliability the bigger we get.
Yeah, and that's honestly sort of the mega trend in storage right now is figuring out how to scale things. Not just how to scale things by adding one more member to the cluster or whatever, but how to scale things in a real, like a scaly way. How do you add 50 of something, not just one of something? How do you make something that grows in single digits instead of growing by doubling? And I think that this topology is, I guess, a step in the right direction for that. And now, in the fiber channel world, we've been doing full mesh topologies for a long time, but this has never been really possible or practical in traditional Ethernet, SANs, using iSCSI and spanning tree and things like that. How does this deal with the fact that you've got way too many links in here for a traditional, spanning tree Ethernet network to deal with?
Well, this is where we're going to start taking some advantage of some of the changes that we've been making in Ethernet and classical Ethernet. You're absolutely right. In traditional Ethernet, the spanning tree would freak out about this, and I think storage admin would have every right to freak out about this. But because of the fact that we've been making some pretty resilient and interesting changes into the actual Ethernet spec, things like data center bridging, which allow us to share traffic as well as keep lossless traffic, and the kind of things that are we doing in IETF and IEEE that will help us do MAC and MAC or MAC and IP, not necessarily all the time for every single solution, but you've heard of Trill and those kinds of technologies allow us to make the Ethernet fabric far more aware and intelligent and self-healing, if I can use such a cliched word, in a sense that when something breaks, you're not going to have to heal the entire system. And that's where I think the advances in Ethernet are going to really create a stable table for putting on our virtualization layer. Because one of the things that we don't want to do in our virtualization of storage or virtualization of applications is put it on a house of cards.
So another point that I wanted to make about this is that as you build larger and larger fabrics with more and more systems interconnected in the same fabric, we run into an issue where we're going to have a lot more activity going on the virtualization side. So for example, we're going to have a lot more vMotions, we're going to have a lot of HA and DRS activity where we're moving virtual machines around. And as we get into a more of a converged infrastructure where we have virtual storage devices, and I think that's where the industry is going, frankly, we're going to be moving storage arrays around logically as well. This network doesn't just need to scale like this, it also needs to have integration with the virtualization layer. And so for me, one of the things that I've been watching in the storage space, and I think a lot of people are getting excited about, is this idea of software-defined networking as a concept. Not just as a concept for, wouldn't that be cool, but as a specific solution for the problem that we're talking about here. In other words, if you've got a virtualization layer and you've got virtual workloads moving around, the whole idea of software-defined networking is that it would let you reprogram the network and more tightly integrate the network with the virtualization layer. And is that really kind of where you're going with this design?
I think that's one of the places that you can go with it. I think one of the beauties about this is that you can go ahead and have a highly integrated virtualization interconnect without causing layer violations. So that you can still, depending upon how you want to draw the picture, you can actually continue to do something that looks like this, as well as do something that looks like an SDN overlay.
Can I suggest another topology here?
You got 30 seconds.
What if you made a ring with hosts?
I'm going to stop you right now.
And you passed tokens around the ring. Would that work? No. Okay.
This is what happens when you ask Stephen to come on before 10 a.m. Thank you very much.
Thank you very much, Jay.
Okay, so my question for you. If this is next gen, understand we're talking future state here, but if people are still having the Ethernet, like where do you see adoption? Where do you see us, I mean, as we talk about software defined, is this so future state because people aren't quite ready for it, or it's the way it has to be?
I'm going to take that one, because this has been really interesting. So Fiber Channel over Ethernet has been out there for a couple of years. Ethernet fabrics have been out there for a couple of years. Adoption is happening in integrated solutions. So you've got a stack, you've got a company that just says, forget it, I don't want to build my own car, I don't want to buy an engine and wheels, I just want something that works. And that's where you start looking at things like a V-block, and that's really where the adoption happens. That's where the adoption for FCOE has happened, and I believe that that's where the adoption for this is happening. Do you agree? Yeah.
All right, so there's one more bit of adoption we need to do. Unicorn adoption. So adopt a unicorn, go. We are off. We have two different styles. This is Stephen's very first unicorn challenge, everyone. All right, we've got two. Oh, wow.
Corn. What is this? That is not a unicorn.
Wow. Oh, wow. Okay, this is a first. So we have a single corn. This is a different model. Hats off to Jay. Hats off, literally.
Hats off to Jay, all right.
Thank you.
Creatively.
And that unicorn had a little too much last night. Just saying. So that's a Vegas corn. Excellent job. Thank you, everybody, this week. Thank you, Jay. Thank you, Stephen. And we'll see you next time on Engineers Unplugged.